In this video, I have a Burle closed circuit camera. This is an early CCD camera. This would, let's see if there's a date on this thing or not. But this goes back to, well, it says date 42. But here's something that you don't see very often. Check this out. Made in USA. It's an American-made camera. Runs on 24 volts AC. So this is connected to an AC transformer that's plugged in over here on my bench. And I just got it plugged into this little monitor that I repaired in a prior video that had the horizontal deflection problem. We'll turn this thing on and you'll see what's going on here with the picture. The picture is just horrible. It's washed out. Crank up the brightness here, and as you can see, the focus is adjustable. There's an adjustable focus here, so it's not a focus problem, but there's a problem inside this camera that is making the picture. You can see it here. See this? We have a filter capacitor problem on this thing. I can just tell by looking at it. There's ringing here. We have a problem there's going to be a DC to DC converter in this thing. I can pretty much guarantee that we have filter capacitors that are going bad. I can just tell by looking at that. So let's get this thing apart and see what's going on with it. One thing that's kind of neat is this uses an auto iris lens. So there's actually a little servo motor inside the lens which adjusts the lens opening depending on the light. The camera itself does not have an auto shutter. Most modern cameras, they have a fixed lens that is wide open all the time, and they control the actual brightness of the video by an electronic shutter, by just speeding the electronic shutter up so that the shutter is open for a less amount of time. The shorter the duration the shutter is open, the electronic shutter, the less light that the photo sensors can gather. This is old school. This runs at 60 fields, 30 frames, and the shutter speed is fixed. So if you have a bright scene, you need to close the iris down. So this works like a real video camera. And this little cable attaches to a plug, and if I unplug it, you'll see that it'll actually close the lens down completely, and now there's nothing at all other than this ringing picture. And this is our problem. This ringing picture is our problem. So I'm just going to get this thing apart. We'll take a look at it. Now remember, this is an AC input, so the polarity is not important. That doesn't matter. There is no positive and negative. I can put these in any direction because this is just a transformer on the other end. This is converting the 24 volts AC to DC, and then there's going to be a DC to DC converter in here, or some types of regulation that will change that DC voltage to whatever voltages are needed. And I've never had one of these open, so this is new to me. I'm just going to look for my little Phillips #1 Phillips screwdriver to get these screws out here. So here we go. Take out the screws on the back, and it'll be interesting to see how this thing is built because I've never seen one of these American-made cameras. I'm curious as to whether the quality of this construction is anywhere like the Bose, those Bose systems that I was working on. Just have to kind of figure out how this thing comes apart. It's all metal, which is kind of neat. Somehow, cover come out. Maybe that cover comes off. Oh, look at that. We have adjustments underneath here. There's another screw. There's a phase adjustment, a back focus adjustment, lens and ALC adjustments. And it tells us here what the pinout is for that connector. So let's zoom in and take a look at the pinout. So our connector, as you can see, it's a 6-pin connector. It's got a drive, positive lead, a damping positive lead, lens video, 9.5 volts DC, a common, and a damper reference. Just all to control that lens. Speaking of the lens, if we unscrew the lens, we can take the lens right off the camera and remove the front of the camera. So let's do that. Let's remove this screw and take the front off. It looks like we just push the whole thing through like that. Interesting. I don't see any plugs here. There's a plug at the back here, but I don't see one up front, so this whole connector must go through just like that. Cool. There we go. Camera slides right out of the cabinet for ease of. There's a little plastic insert there to screw the tripod, looks like, into, or the mount. Oh, that's what that's for. That's so that. Cool. So that fits inside there. That's so that if you put a screw down there and you put too long a screw and you're not going to short something out, it's got a little base on it just to hold the screw in place. And there is the guts. There's the little black and white sensor. Maybe a little too close to focus. There's the CCD sensor. A little bit of dirt on there. And I see some electrolytic capacitors, and I see some of those ugly, ugly surface mounted electrolytics. Ugh. And you bet that they're going to be bad. And inside this box here, I'm gonna go out on a limb and say that's the DC to DC converter. I bet you the problem's going to be inside this piece here. So here's something that's kind of neat. This barrier can be slid right through for accessing the board. And let's take this bracket. Oh, the bracket's soldered on back here. That's a shield. But this other board looks like it will fold out of the way. Yeah, maybe it's attached. Looks like it might be attached to the shield as well. But first things first, let's get in there with the ESR meter and just measure some of these capacitors, these surface mounted capacitors here, the surface mounted electrolytics. They generally tend to be the most problematic. Before I do that, let's just take a look at the circuit board here. Construction on here seems to be first rate. Soldering looks excellent. Look at this. Like, this is first rate construction. That's what it looks like. Someone's been in here too. This has been serviced at some point. That pin has been unsoldered. That has to be unsoldered to fold the board down. But look at that construction. That's beautiful. Be no BGA mounting components in this thing. It's all going to be surface mounted and a few through hole parts. Let's first of all see if we can flip this board down. We'll just heat this up. Look at that, eh? Beauty. Now we get a look at the top side of that board. Looks like this cap has been changed. Someone's changed that cap. And I'm looking down here at some of these other surface mounted electrolytics, and they look like there's crap leaking out of here. Look at this down here. It looks like that one's been leaking. Kind of looks like it from this angle. That one may have been leaking. The other ones don't look like there's anything spilling out of them at this point, but that one there, it looks like it's seen better days. Let's get the ESR meter and just take a measure and see how they look. So let's just test a few of these capacitors out here. You can see the meter, and we'll take a look. Here's this first one down here that I suspect is bad. Ah, yeah, it's open. That one's bad. And how about this one? This is a 33 mic at 6 volts. Kind of looks like, I don't know, maybe I'm not getting a good connection, but it looks like that one's bad too. And how about this 10 at 25 volts? 26 ohms, yeah, that one's bad. And this one over here is bad. And this one over here is bad. I think we got bad caps in this thing. This whole thing is full of bad caps. And the question is, do I really want to fix this thing? Well, that one actually measures okay. That's the first one that's okay. It might just be these ones over here. This might be in the power supply. How about this one over here? Yeah. And there's also, looks like that one's also bad. And there also, it looks like it's bad. That one there is bad. Yeah, this thing's full of bad caps. Now the question is, do I want to fix this thing, or do I not want to fix it? It's one of these situations where I ask myself, am I going to spend the time to repair something that really I don't have any use for, other than the educational value of making it work? And that might be the only reason why I consider changing all these capacitors on here, is just because it might be nice to see it work. But, and this is a big but, I think in this case we know where the problem is. It's going to be these filters are bad. That one, a couple more over here. These filters are all bad. And maybe we'll just call it a night, and this thing will go back on the shelf, and may do this for a future project. Again, this is something that I've had for ever. It was given to me in a box of old electronics as non-functional, and it is non-functional. Even when this is working, it's not going to have a great picture because of the age of this thing. It might be just nice to try and fix it just for the heck of it, just for the nostalgia of fixing this old thing. And that's what I'm looking at. If it had just been one capacitor or two capacitors, I would have done it in a heartbeat, but it looks like all these surface mounted electrolytics are going to have to be changed out. And I'm not quite sure that I really want to spend the time to do it, if you know what I mean. I don't generally give up on electronics like as quick as I did on this one, but I think you'll agree, after looking at that, and I went through it with the ESR meter, every single electrolytic capacitor on that board needs to be replaced on both of those boards. Every single one of them. The ESR is through the roof. Most of them won't even measure. They're over 100 ohms. I'm sure recapping this would fix the problem. It's something that's not worthwhile to do. I don't have the parts in stock. I'm not going to bring a bunch of surface mounted caps in just to change this for something that's going to sit on the shelf, because I really don't have a use for it. So I'm going to give this one the thumbs down. I'm not fixing this one here. You guys got to see what the inside of this little Burle camera looks like. It's kind of a neat little unit. I'm not going to toss it in the garbage just yet. Maybe someday, if I'm really extremely bored, We know where the problem is on this one now. We know how to fix it. Maybe I will revisit it at some point, but at this point in time, this one's going back in the box that it came out of, where it can sit for another 10 years. Let me know what you think. If I get enough support, people wanting to see this thing overhauled, then maybe when I get some time and I've got nothing else better to do, we'll sit down and start recapping this thing. I'm not saying no forever, but I'm going to say no for now. We'll catch you in the next one. Bye.